me start recording. So again, our learning objectives for today are at the end of this lesson, what you should be able to do is to compute for the number of protons, neutrons, and electrons per element. So if you already have your periodic table with you, if you have your calculators, your notebooks, and your pens, then let's start with the lesson. Okay, so the first two people who actually conceptualized or started to think of something that is smaller than molecules is actually Democritus. So as early as 400 BC, Democritus already have this idea that matter, your solid and your liquid and gas, they are made up of molecules, and these molecules are made up of smaller substances, which allows them to be divided indefinitely. Okay? So sabi niya dito, may mas maliliit pa dyan sa mga yan. Even if we cannot see them with our naked eye, these matter can be divided into smaller molecules, and these smaller molecules can be further divided into what we call as atoms. And it was actually Democritus who coined the idea of atomos or atoms. So sabi niya, these molecules are made up of smaller materials, and he called them as atoms. So ito yung idea ni Democritus na lahat ng substances in our planet can be further divided into smaller substances. Okay? And si Aristotle naman, he had a different idea from Democritus. In 350 BC, Aristotle modified the theory of matter. So sabi niya, hindi atoms tong mga to eh. These substances can be further divided into what he called as elements. And these elements are composed of the earth, fire, water, and air. So medyo mas familiar tayo dito sa idea ni Aristotle, especially if you're someone na nanunood ng mga anime such as, sino yun? Si Ang, di ba? They also handle yung different elements. So syempre itong rocks, it is made up of smaller earth materials, whereas yung mga nakikita nating bodies of water are made up of the fire element. So ayan yung naging idea ni Aristotle. But between the two, it was actually Democritus na mas naging tama yung idea niya. Tama rin naman si Aristotle that there are different elements. But when it comes to matter and to the molecules, mas naging, mas aligned yung naging idea ni Democritus. So from this idea of something smaller, or itong idea of having atomos or atoms, diyan idinugtong ng ating third scientist yung kanyang idea. And the third scientist is, ayan. So Aristotle was wrong nga daw. Pero syempre naniwala yung mga tao sa kanya. Kasi syempre observable, very easy to observe yung four elements in our nature. So it was Democritus who had the right idea all along. And our third scientist, itinuloy niya yung idea ni Democritus of having smaller substances that we cannot see. So the third scientist is who we call as John Dalton. So si John Dalton, he developed what we call as the atomic theory. And in this atomic theory, meron siyang tatlong postulates or three statements. Ito yung tatlong statements of the atomic theory. So sabi niya, all matter is made up of atoms. And ito yung continuation ng idea ni Democritus as early as 400 BC. So sabi niya, di ba, lahat ng substances on our planet, on our earth, you can divide it indivisible, di ba? As many times as you can. Sabi niya, all and the smaller particles na nakikita that is made up of these substances, he called it as atoms. So same idea sila ni John Dalton, itong si Democritus, that everything here is actually made up of atoms. And then he said that atoms are indestructible and cannot be divided into smaller particles. So ano ang naging idea ni John Dalton? Ang sabi niya dito sa second statement is that atoms are the smallest. Di ba? Hindi mo na siya pwedeng paliitin pa at wala na daw mas liliit pang particle dito sa atoms na to. So sabi niya, atoms are indivisible. Hindi mo na siya kayang paliitin pa. Siya na yung pinakamaliit. So kung meron tayong rock, these rock are made up of earth molecules, and these molecules are made up of the same atoms. Pero in John Dalton's idea, those atoms are the smallest possible. Hindi mo na daw siya pwedeng paliitin. And sabi niya ganon, all atoms of one element are exactly alike, but are different from atoms of other elements. So for example, sabi niya, kapag ka-fire element siya, ibig sabihin, yung atoms nila doon sa loob ng fire element na yun, pare-pareho. Pag water element siya, ibig sabihin, yung atoms doon sa water element, pare-pareho. Pero magkaiba yung atoms ng water at saka ng fire. If we are going to apply this idea to our idea of elements ngayon, such as meron tayong gold, meron tayong silver, meron tayong copper, the same yung idea ni Dalton. Pare-pareho yung atoms na makikita natin na nasa loob ng isang gold element. And pagdating sa copper, pagka zoom in natin siya, sabi niya, iisang atoms yung makikita natin sa loob ng copper element. Pero pag pinag-compare na natin yung atoms that is found in gold and the atoms that is found in copper, syempre magkaiba na sila. Kasi magkaiba na rin yung element. Okay, so these are the ideas of John Dalton. And ang pinaka-primary idea niya is that the atom is the smallest particle. So anong itsura ng smallest particle na yon? Wala lang, basta sabi lang ni John Dalton, yun na yung pinaka-maliit. So if we are going to conceptualize kung ano ang itsura ng atom sa paningin ni John Dalton, it's merely a spherical. Yan, bilog lang siya. Basta yan lang daw yung pinakamaliit. At pag nag-zoom in tayo sa loob ng isang copper, pare-pareho yung atoms na makikita natin sa loob ng isang copper. So yan yung idea ni John Dalton about what atom is and what atoms look like. Okay? So now let's continue to the other scientist. So the second one, wait lang, alisin natin yung ating drawing na pangit. Okay? Okay. So si Dalton, ito yung tinatawag nilang billiard ball model. Kasi ang idea lang niya is that atoms are solid and that atoms are the smallest particle which makes them indivisible. But the fourth scientist who we know as J.J. Thompson, si J.J. Thompson naman, he conducted an experiment using cathode rays. So pakita ko sa next slide yung ating cathode ray. Ito yung itsura ng isang cathode ray experiment na ginawa ni J.J. Thompson. So what he does is, he is going to choose one substance and then he is going to rub the substance in this area of the cathode ray. So i-rub niyang ganon. Tapos this cathode ray uses electricity. Tapos napansin niya na kapag nirarub niya yung isang substance on this part of the cathode ray, the electricity was able to separate the particles of this substance into positive and negative parts. So yung cathode ray niya kasi ay meron siyang anode. Anode kasi is for the negative parts. Tapos meron siyang cathode for the positive parts. So nakita niya doon sa experiment niya na pag nirarub niya yung isang substance, for example, gold foil, nirub niya on this part of the cathode ray, naghihiwala yung particles niya into positive and negative. Okay? So yun yung naging result ng study ni J.J. Thompson. So because of the result of J.J. Thompson, napatunayan niya na mali itong idea ni John Dalton. Specifically, anong idea ni John Dalton ang napatunayan ni Thompson na mali? Can you guess? Kung ano dito sa tatlong postulates na to ang na-disprove nitong si John Dalton. Can I ask Rian?
Sir, the second one.
The second one. Can you explain why, Ate Rian?
Because it is said there that atoms are indestructible and cannot be divided into smaller pieces. But another scientist used cathode rays. He was able to separate the negative and positive parts of atoms.
Okay, thank you very much, Ate Rian. So yes, na-disprove nitong si J.J. Thompson na mali itong second postulate ni John Dalton. Tama yung one, kasi all substances are really made up of atoms. Tama rin yung 3, that an element is composed of the same atoms. The same in our body that an organ is composed of the same cells, of the same tissues. Ganon din itong third postulate niya. So tama yung idea ni John Dalton in terms of 1 and 3. Nagkamali siya dito sa number 2. Kasi ang sabi niya, itong atom na yung pinakamaliit. Wala nang mas liliit pa sa atom. Hindi mo na nga daw siya, di ba, pwedeng i-divide into smaller particles. But when it comes to the cathode ray experiment of J.J. Thompson, na-discover niya na there is actually something smaller than the atom. Kasi the atom in itself is made up of positive particles and negative particles. So ngayon, originally, we believe that an atom is just a circle or a sphere na wala siyang laman sa loob. But actually, it's not. Kasi meron na siyang positive and negative particles or what we call as subatomic particles inside of these atom. And the positive and the negative subparticles are discovered by J.J. Thompson in his experiment using the cathode ray. Okay? So, ang naging idea ni J.J. Thompson is that an atom looks like a plum pudding. So, a plum pudding, para siyang blueberry muffin. Sabi niya ganon, dito kay sabi ni Thompson, yung there is a positive sphere of cloud surrounding this atom. So kung i-compare natin siya sa blueberry muffin dito or sa isang plum pudding, yung tinapay is actually the positively charged particles. Tapos, interspersed or nakahalo daw doon sa positively charged na sphere of cloud are the negative electrons. So, pag tinignan natin itong blueberry muffin na to, yung mga blueberries dyan, yan yung mga negative electrons. Okay? Or kung gusto nyo ng chocolate chip cookies, kung mas madaling i-visualize sa utak nyo yon, yung cookie in itself, yung tinapay, your dough, is the positively charged. And then yung mga chocolate chips na nakahalo doon sa cookie mo, those are the negatively charged. So you have to remember na meron na siyang dalawang subatomic particles na nasa loob ng atom. The positively charged are what we call as your protons. So let me write that down. So the positively charged particles are what we call as your protons. And then of course, we have the negatively charged particles that we call as your electrons. Okay, so hindi na nga lang siya bilog na katulad nung na-imagine ni John Dalton. Meron na siyang subatomic particles sa loob niya, smaller than an atom itself, which implies that an atom can be divided into smaller particles. Kaya na-disprove ni J.J. Thompson yung idea ni John Dalton. Okay? Are we still okay with the different scientists? Pa-thumbs up sign kung nakaka-follow pa. Thank you very much. Okay, so now let's go to the next slide. Clear ko muna. Okay. So the next scientist, panglima na to, di ba? Panglimang scientist na to. So the first one was Democritus. The second one was Aristotle. The third one is John Dalton. And the fourth one is J.J. Thompson. So the fifth one is si Ernest Rutherford. So si Ernest Rutherford, he created a different experimental setup. Okay? So this is... Wait lang ah. May mas maganda kasing drawing sa next slide. Yun. Okay. So this is the thin gold foil experiment na ginawa ni Ernest Rutherford. So what he does is meron ditong beam of light, laser light. Tapos itong light na to, tatama siya dito sa isang thin gold foil. Okay? So, patatamaan niya ng laser itong gold foil na to. And, na-observe niya na iba't iba yung naging result depende sa kung saan niya pinatatamaan itong laser. May mga, minsan daw, itong laser dumidiretso dito. So, tumatama siya on one side of the plate. Ibig sabihin, tumagos siya dito sa thin gold foil na to. Pero hindi daw sa lahat ng pagkakataon. Merong mga times na kapag nagdidirect siya ng laser beam dito sa gold foil, hindi siya tumatagos on the other side. But instead, it was actually reflected or refracted. So, hindi siya tumatagos dito sa gold foil. Tumatama siya on the other side. Bumabalik siya. So, if we look closely at this picture, ayan. Ito yung mga tumatagos na laser beam. Itong laser A, itong laser B, tumatagos yan. Pero merong mga times, tulad nitong laser C, na hindi tumagos yung laser beam. But instead, it was actually refracted. So sabi niya, wait lang, meron atang something sa loob ng atom na very dense ang kanyang mass, mabigat siya compared to other parts of the atoms. Yung ibang part ng atom, sabi niya, magaan lang yon. So pag tumatama yung laser doon, dumidiretso lang yung laser. Pero meron daw part somewhere in the middle of these atoms na denser siya, mas magbigat siya compared to the other parts of the atoms, na kapag tumama doon yung laser, nagba-bounce back itong laser. Hindi siya tumatagos doon sa gold foil. So sabi niya, meron akong tinatamaan dito na very heavy, very dense, which allows the particles to bounce back. So, saka nagkaroon sila ng idea about what we call as the nucleus. So, yung denser part of the atom, sabi ni Ernest Rutherford, somewhere in the middle is a dense part of the atom, and he called it as the nucleus. Okay? And sabi niya, sa loob ng nucleus, doon niya makikita yung positive na particle ng isang atom. Okay? So, una, ang naging idea lang nila kay John Dalton is that an atom is just a circle, a sphere. And then, pagdating kay J.J. Thompson, nagkaroon na siya ng positive and negative particles. Pagdating kay Ernest Rutherford, nagkaroon na siya ng idea of a nucleus. At yung nucleus na yon, sabi niya, nandoon yung positive na particle ng isang atom. Hindi siya katulad nung idea ni J.J. Thompson na yung tinapay yung positive. Sabi niya, no. Yung positive is actually just in the middle, inside the nucleus of the atom. And then the negative parts, the electrons, yun yung nakakalat sa labas ng nucleus. So ngayon, meron na tayong nucleus, meron na tayong protons, and meron na tayong electrons. Okay? So ngayon, let's go to the last scientist, which is si Niels Bohr. Si Niels Bohr, sabi niya, I think that atoms, they actually look like your planets. So meron nang nag-orbit sa kanila. So sabi niya, if this is the nucleus and the protons are inside, the electrons are like planets. They are orbiting around the nucleus. So itong electrons daw, merong nag-orbit dyan sa labas ng nucleus, and those are your electrons. And sabi niya, each orbit indicates different levels para doon sa electron. So habang dumadami daw yung orbit na umiikot dito sa tinatawag niyang nucleus, mas tumataas yung energy na napoposes nitong mga atoms na ito or ng elements na to. And later on, i-continue sa grade 9 itong idea ni Niels Bohr when you learn more deeper about dito sa electrons, electron excitation, at saka yung other parts of the elements. Okay? So ngayon, ito na yung naging idea natin based on the idea of Bohr and Rutherford. Sabi natin that there is a nucleus in the center of the atom, and inside the nucleus is what we call as your protons, or the positively charged particles. And we also have what we call as your neutrons. These neutrons are the neutrally charged particle. It's not positive and it's not negative. And then around these protons, we have the electrons, the negatively charged particle that is revolving or orbiting around the nucleus. Okay? So, ayan. For example, this is helium. Helium has an atomic mass of 2. So, ibig sabihin, may dalawang electron siyang nag-orbit. The same when it comes to lithium. Lithium kasi has an atomic mass of 7, I think. So, meron siyang ganyan. Okay? So, now, let's try to learn kung paano nga ba mag-compute for the number of protons, electrons, and neutrons. So, when you look at your periodic table, you will see different information about your elements. The first one is the symbol or the element symbol, usually made up of one letter, or in some cases, meron siyang 2 letters. For example here, helium has a chemical symbol of He. Hydrogen has a chemical symbol of H. Okay? And then, merong dalawang important na number about this element helium. Yung number sa taas is what we call as the atomic mass. Okay? So, mass number yan, or the atomic mass. And then, doon sa baba yung tinatawag nating atomic number. Okay? You have to remember, yung atomic number, ito yung pagkakasunod-sunod nila sa periodic table of elements. So, for example, hydrogen is the first element. Ang atomic number niya ay 1. Helium is the second element in the periodic table. So, ang atomic number niya ay 2. So, yung pangatlo doon, yun yung number 3. So, yun yung atomic number. Yung atomic mass, ito yung bigat niya. So, if you will look at your periodic table of elements, may mga atomic mass dyan na merong decimal places. Hindi siya talaga whole number. So, for example, bigay tayo. Let me open my periodic table. So, for example here, calcium. Calcium has an atomic number of 40.078. Okay? So, hindi talaga siya whole number, and that's okay. Pero when it comes to atomic mass, you just have to round it off into a whole number. So, for example, itong calcium natin, ang kanyang atomic mass ay 40.078. Therefore, if I'm going to round it off, ang atomic mass niya ay 40 or 40. Okay? Nagkakaintindihan ba tayo dyan? Thumbs up sign. Thank you. Another, itong sodium. Ang atomic mass ng sodium ay 22 9897. 9897. So, ang kanyang magiging atomic mass ay 23. Okay? So, you just have to round it off into the nearest whole number. And this is important kasi pagdating sa computation, kailangan whole number ang iyong atomic mass. So, how are we going to compute that? So, sabi natin, based on the discoveries of the different scientists, we actually have 3 subatomic particles. The positive one, which is your protons, the negative one, which is your electrons, and of course, the neutrally charged particles, which is your neutrons. Okay? So sabi niya dito, very important tong hahanapin ninyo yung mass at saka yung atomic number. Another example here is oxygen. Oxygen is the 8th element in our periodic table of elements. So ang kanyang atomic number ay 8. Pero ang kanyang mass, atomic mass is 16. Okay? So now let's continue with that idea. So paano tayo magko-compute? So these numbers, they tell you a lot about your atoms. So sabi niya dito, the number of protons is just the same as the number of electrons. So kung gaano karami yung proton sa isang atoms, automatic ganun din kadami yung number of electrons. At makikita natin yon depending on the atomic number of the element. So kung ito ang ating example, helium, ang atomic number niya ay 2. So ibig sabihin, dahil alam ko yung atomic number niya, ibig sabihin, alam ko na rin na meron siyang 2 protons at saka meron siyang 2 electrons. Kasi ang sabi niya dito, the atomic number will tell you the number of protons and the number of electrons. So kung babalikan natin itong example kanina, si oxygen, na merong atomic mass of 16 at atomic number na 8. So dahil alam natin yung atomic number niya, which is 8, ibig sabihin, alam na natin na meron siyang 8 protons at meron din siyang 8 electrons. Okay? Malinaw ba yon? Grade 8? So para malaman natin ang number of protons and electrons, kailangan nating makita kung ano yung atomic number niya. Okay? So now let's continue. Itong atomic mass na to, sabi niya, ito yung bigat ng isang nucleus ng isang atom. Okay? So itong atomic mass ay yung bigat ng nucleus ng isang atom. And ano nga ba ang nasa loob ng nucleus? Inside the nucleus, we can find the neutrons. At the same time, we can find the protons. So kung ang atomic mass ng helium ay 4, ibig sabihin yan yung number ng neutrons and your protons. Automatic alam na natin yung kanyang proton. Ang proton ng helium ay 2. Ibig sabihin, the number of electrons is 4 minus 2. Therefore, it is also 2. So for helium, ang kanyang proton ay 2, ang kanyang electron ay 2, ang kanyang neutron is also 2. Okay? Let's try the idea of oxygen. So sabi niya dito, oxygen has an atomic mass of 16 and an atomic number of 8. So automatic niyan, proton is equivalent to 8, electron is equivalent to 8. Our atomic mass is 16. Therefore, to find the neutron, we are going to subtract the atomic mass to the number of proton. Therefore, neutron is also 8. Okay ba tayo dyan, grade 8? Okay, sige. Now, let's have some exercises on the next slide. Okay, So bring out your periodic table of elements and please give me the atomic mass and the atomic number of calcium. Miss C, can you give me the atomic number of calcium? Or anybody from the class to give me the atomic number of calcium. Atomic number yung nasa ibabang number, depending on the arrangement of the periodic table of elements. Nasaan si
20.
Mickey? O sige nga, Kuya Marvin, ikaw na lang. What's the atomic mass of, atomic number of calcium?
Atomic number of calcium is 20.
20. Okay. How about the atomic mass of calcium? Ano yung bigat ng calcium?
40 po, sir.
40. Okay. So using these numbers, how many protons can we find in calcium? Marvin pa din.
Protons, sir, 20 pa din, sir.
Bakit siya naging 20, Kuya Marvin?
Kasi, sir, yung atomic number niya, sir, is 20.
Okay, so dahil yung atomic number niya ay 20. Tapos sabi natin, yung dami ng protons, yun din yung dami ng electrons. So automatic, 20 din yung kanyang electrons dito. Now, can we compute for the number of electrons? How many neutrons can we find in calcium? Kuya Mavs?
20 din po, sir. Kasi, sir, 20 po yung protons. Therefore, 40 minus 20 is 20.
Thank you very much. Okay, so nilipat natin yung 40 dito para makuha yung neutron. So, minus na natin yung 20 doon sa 40 na yon. Kasi sabi natin yung 40 na yan, ang katumbas niyan ay yung number of protons at saka number of neutrons. Okay? Next, Jean Kurt, can you find the atomic number and the atomic mass of argon?
Their atomic number 18.
18? How about the atomic mass?
Their 39.
39. So what's the number of protons?
Their 18.
18. And electrons, how many?
18 din, sir.
18. How about the neutrons?
Their 21.
21. So paano nangyari yung 21? This is 39. Is equivalent to protons plus neutrons. Ang protons natin ay electron. Therefore, the neutron is 39 minus 18 equivalent to 21. Thank you very much, Jean Kurt. Mag-i-end ang aking